So here, the first thing on this review is the empirical rule. So the mean is 64.9 and the standard deviation is 1.8. I will try to do that on here so you can see it. So what I have you do on the test work page is go ahead and label that 64.9 and 1.8. So the mean goes in the middle, and then you add 1.8 as you go to the right. So add 1.8, add 1.8, add 1.8. And then as you go to the left, you subtract 1.8. Doing this will help you do the problem. That's what I kind of try to do on these harder tests or harder problems. Okay. The rule here, you don't have to do this part, but the rule here is that you are 68%. 68% between the first two, 90 or 95. So if you're, I'm sorry, let me say that a different way. If you're 1 standard deviation away from the mean, it's 68%. If you're 2 standard deviations away, it's 95%. Sorry, on my end there was a glare. So 1 standard deviation away is 68%. 2 standard deviations away, 95. If you're 3 standard deviations away, it's 99.7. Okay, and again, this chart's kind of there to help you do the problem. So if I go back to the problem, it does look like I'm a little bit less than 62, a little bit more than 68. Sorry, it's a little easier for y'all to do it on your, then you don't have to go back and forth. So a little bit less than 62 would be 61.3 and 68.5, 61.3. 68.5. We put the mean in the middle. That was 64.9. So you just have to figure out which one of those ones that we came up with on the test worksheet. And it looks like it was when we added it twice. So it is 95%. All right, number 2 is on our test work page as well. Number 2 is a Z-score problem. River Valley College and Elm College are 2 local colleges. For each college, the distribution of the age faculty members is clearly bell-shaped. The ages that is important, that clearly bell-shaped. I'll talk about that at the end. But the age of the faculty members at RVC have a population mean of 33 and standard deviation of 1.9. The age of faculty members at Elm College have a population mean of 63 and 7. Yolanda's 28, Mary's 37. Find their Z-scores. So 37, 33, 1.9. 37. Let me see if I wrote it down correctly. 33, 1.9, 30. Oh, she's 28. Yolanda's 28. We'll do one at a time here. Okay, so Yolanda, that's our age. Our mean is 33, and our standard deviation is 1.9. The Z-score formula, I should have gave it to you on this page right here, and I didn't even think about putting it on here. So remind me on test day, and I will write it down for you. X minus the mean divided by the standard deviation. It's the... man, I should have gave that to you. I didn't even think about it. It's the data value minus the mean divided by the standard deviation. So for Yolanda, we do 28 minus 33. She's younger than the average, so it should be a negative number. 28 minus 33 divided by 1.9 is Z equals negative 2.63. Okay. The other one, Mary, is 37.63.7. 37.63.7. 37.63.7. So the mean is 37. I'm sorry. The data value is 37. That's Mary. That's who we're looking at. The average age is 63 divided by 7. 37 minus 63 divided by 7 is negative 3.71. It says in your owns, what is the Z-score? And the way I would say that is the way I would say it, but it's in your own words. How many standard deviations away from the mean. Okay. So that is kind of a lot to write in that box, but it shouldn't be too bad. I didn't really do a good job of spacing there. All right, 2.63 and 3.71. Negative 2.63 and negative 3.71. So relative to our population, who is the younger faculty member? Younger would be less than the average, so Mary is younger on that one. Now, what I want to say here real quick is you can only compare z-scores if it is clearly bell-shaped. So that's why they say that. So this means we can compare z-scores. Okay? So if it says clearly skewed, it would be unclear. So we'd use this as our answer right here. Okay? That is kind of a trick question there. This is one of the ones that you can still get the first part right, so you'd get most of the points for the problem. But if it says clearly skewed, that means we cannot compare their z-scores, so we would use that part C for our answer. It is unclear. Like I said, you'll still get most of the points if you don't get that, but I just want to point that out. Number 3. It looks like a normal distribution problem. So an aptitude test. We got to do this on our paper. Show your work. If using the calculator, right, what you put in the calculator? Yes. Yeah, an aptitude test is designed to measure leadership abilities on the test subject. Suppose that the scores of the test are normally distributed with a mean of 570, standard deviation of 125. The individual who exceed 700 on this test are considered to be potential leaders. What proportion of the population are considered to be potential leaders? All right. So we are looking for the greater than of this. Let me real quick. Well, I'll talk about it. Okay. So we can do this all in the calculator. We can use our z-score formula. So the first thing you always need to do is change it to a z-score. So we're looking at exceed 700. So that would be 700 minus the mean 570 divided by the standard deviation is 125. That's what we just did, the z-score formula. X minus the mean divided by the standard deviation. You've probably done that enough. You know that formula. So you can find the z-score first, but I'm just going to go ahead and put it all in the calculator. Now, the issue with what's in the calculator right here, and I can't highlight it. I'll do it just a sec when I screenshot it, but I want to get the answer first. The issue with this is z is less than or equal to, but I want the individual who exceed. So I want it to be greater than or equal to. So anybody remember how we flip that sign in the calculator? You do 1 minus that number, and that's going to flip the sign in the calculator. Let me get my answer real quick, and then I'll kind of draw a picture to show that. 1492. Okay. So that is what you could write on your test work page. Is this what I have in the calculator right there? So we are going to use this button on the calculator. The issue is we want exceeds. So our mean right here, just to draw a quick picture, 570. We want 700 or more. So we want anything over here. Okay. So what we do in the calculator is we find, the calculator finds everything to the left, and then we do 1 minus over here. So this would be, I'll just do it real quick, 1 minus 0.1492. This would be like 0.8508, so this would be 0.1492. So that would be like 85% to the left, and then you flip it to 100% minus the 85% would be 15% to the right. Okay, so if you want to flip the sign, to flip sign, do 1 minus. Okay. And then just to write this here, just so we have it, even though we did it the last problem, this is x minus the mean divided by the standard deviation. y'all answered the 1 minus there quick, so that's good. So on this test work page, you could just write, what was it, 700 minus 570 divided. What was anybody write down the standard deviation?
125.
125, thank you. You just like write that in there. All right, number 5 is the next one we need on the test work page. Number 4. PCB is an organic pollutant that can be found in electrical equipment. A certain kind of small capacitor contains PCB with a mean of 47.5, standard deviation of 8. A government agency takes a random sample of 40 of these small capacitors. The agency plans to regulate the disposal of such capacitors if the sample mean is 48.5 or more. Okay, so the only thing different on this one, instead of sampling 1, we are sampling 40 of these. So we have to change our standard deviation. This one, again, is more, so we're going to do 1 minus, but we'll talk about that in a second. So find the z-score. My z-score is 48.5 minus my mean, 47.5. Now, here's where divided by the standard deviation is 8, but we are sampling 40 of these. So what I'm going to do, since I'm sampling 40, is I'm going to click divide again, and I'll write the formula out when I do the screenshot. But I'm going to do divide it by the square root of 40 since I'm sampling 40. The last one was, what's the probability that we pick one person that's a leader that exceeds 700? This one, what's the probability that we pick 40 and their average is going to be greater than 48.5? So anytime you pick more than one, you have to divide by the square root of n, which is how many you're picking. Okay? And it says we want to know when it exceeds 48.4 at 5 or more. So like y'all said, we do 1 minus here. And we get equals. Let me go ahead and write this answer, and then I'll screenshot it and draw you a picture for 6. Oh, wait. I need more than that. I need that. Okay, so again, what we're really looking at here, whoops. Our mean is 47.5. We want, when we sample 40, for the average to be greater than 48.5. So we are looking in this area over here. So again, we do to the left in the calculator. If we do to the left in the calculator, that would give us the 7854. So the one we actually want is to the right, which is 0.2146. This formula is x minus the mean divided by the standard deviation over the square root of n. Okay, so again, we do 1 minus to flip the sign. Y'all good on those? All right, number 5 moves on to confidence intervals. I'm not going to read that all because we do a sample of 40 and do a 90% confidence interval. So we sample 32 people. The point estimate, our average of these people is 5.15. What are we doing? How long it takes to do heart surgery. So 5 hours and 15 minutes. The population standard deviation, make sure you turn the population one, not the sample one. That's 1.92. The critical value for 90%. The way you do this is 90% is on the inside, so you got 10% on the outside, and you got 5% on each side. So I'll write the formula out, I'll draw the picture in just a second. But 90% is saying the inside, you want 90% towards the middle, which leaves 10% on the outside. And you got 5% to the right, 5% to the right. Now I say all that because now the one I'm looking at would be this 1.645. And that should give me my answer there. So you just have to choose which one of those goes along with 90%. Again, if you want to see that in like a calculator form, 1 minus 0.90. So that gives me the outside, and then I divide it by 2 because you could have some on the right and some on the left. So you use 0.05, that 1.645 there. When I draw a picture, it might make more sense. So I click compute, and I get 5.15 plus or minus 0.56. There is a plus or minus button, so with a margin of error, You are adding it to the point estimate and subtracting it. So you get two numbers here, 4.59 and 5.71. Okay, so that's what we're 90% confident that if we measured all the heart surgeries, they would be between those two numbers. But they are claiming that heart surgeries only take 4.27. Okay, so we are confident that it does contradict the claim, and it would be outside that 90% confidence interval. I know this is a little harder for y'all to see when I screenshot it like this, but just give me a second, please.
So the only, in that box where it says like, so if it says 90, right, but if it said 95, so we just take 1 and minus like 0.95, or how you just did it, like 0.90 and then divide it by 2, and then that's what the Z one that we would use?
Yes. So what I did there, and it's a little easier if you can see the picture, to figure out the critical value is like the hardest part of this problem. So the way I think about it is, if you have the normal distribution that we were just doing, what you're looking for really is that you're saying this is 90%. Okay, that's 90%. So you're trying to figure out what z-score goes along with 90%. Okay? So the way the calculator works, or the way you always see these numbers, is we would say if there's 90% on the inside, then that means there is 10% on the outside, and there'd be 5% on each side, if that makes sense. So what that does in formula world is 1 minus the confidence level divided by 2. Okay, so I did 1 minus 0.90, 1 minus 0.90 divided by 2 would be 0.05. Oh man, on my screenshot I clicked over it, but it would be, we would use this one right here, the 1.645. So that tells you which one to use there. That makes sense? 1 minus the confidence level divided by 2. And then everything else is just basic calculation, because this right here is 5.15 plus 0.56 and 5.15 minus 0.56. So the hardest part of this one is that critical value. And if you just have this formula handy, I don't give you that formula necessarily because that is just a thought process formula.
So that's helpful, because when I was doing these, sometimes I was getting confused on like which one. So
Oh, you know what? I just drew that picture. That is helpful to, oh yeah, which one to do there. This one is on our test work page, right? I put this picture here to help you remember which one to do there. So that picture that I just drew is what I want on your test work page. My goodness, that thing is, oh, okay. That's fine. That's strange. Sorry, it's gonna really bug me that it's like dark blue on some spots, and that's fine. Okay, so this is saying that this is 90%. So that leaves 10% on the outside. So this would be 5% and 5%. So that's where the 1 minus the confidence level divided by 2 comes in. So what we're trying to figure out is what number goes here. And that chart tells us the one that goes with 5% is 1.645 or negative 1.645. Now we just need the positive. That's where the plus and minus come from anyways. Like you add and you subtract for a positive and a negative. These come from the chart. But yeah, that I drew that picture there, or I have y'all draw that picture there just to help you do that, find that critical value as well. All right, I believe the last 5 on this test may be all like critical, or oh no, this is another confidence level. So here, the same thing, but a proportion, 90% confident level. My sample size here would be how many people we asked, which is 40. You may have to add those up, 26 and 14. It does say it in the problem at the top 2. The point estimate, we are looking at the people who prefer printed to electronic, which would be 65%. The critical value here, it is 90%, so it's going to be the same as we had last time, the 1.645. But again, to figure that out, 1 minus the confidence level, 1 minus 0.9, divided by 2 would be 0.05. So that tells us the 1.645. And then we get our number there. sorry, 0.65 plus or minus 0.123. It's pretty big. Is 0.527 and 0.773. And the study says 0.44. So that is outside. It does contradict the claim. They told us it was 44%, whereas it's actually 65%. I was trying to think of somewhere I could. I think that should be fine. We can see everything if I do that. So just real quick here. What are we doing? The critical value, again, 1 minus 0.90 divided by 2 would be 0.05. So that tells me to use this one. This number here is 0.65 minus 0.123. And this one is 0.65 plus 0.123. I don't think there's anything else I need to say. This is 40, right? If I add those up, it's 40. Okay. Just when y'all go back and look at it, you don't have to watch the video. You can just skim through these pictures, hopefully, and all right, number 7 is on the test work page. Okay, let's do the test work page first before I do the problem. This is just the basics of hypothesis testing. Hypothesis testing just says the null hypothesis is always equal. Okay, that's always equal, so we use that one there. The alternative is going to be less than, greater than, or not equal to, and the way you find that is you have to just read the problem. So pretty easy on the test work page here. You can do that one right when you get your page. It has nothing really to do with the problem. Just a reminder, though, that the null hypothesis is always going to be equal, and then the alternate, you can read those to get it. All right.
Could we also for that put like H0? You know how like it's like H0 then H1, kind of how you write them out? Do you put that there too, or you want us to write that?
Yeah, this is, so H0, the null hypothesis is H0, and this is, do they say H1 or HA? They say H1, don't they? Yeah, that's fine. Yeah. Yeah, I guess all the problem says right there. All right, so the first one is just a basic hypothesis testing. You have a problem here, and it wants the mean is less than 8. So it is less than, that's going to be a one-tail test. If it's less than or greater than, it's one tail. If it's not equal to, it's two tail. They give you the critical value on this one. The test statistic is negative 0.942. So now we look at this, and our test statistic is outside of the rejection region, so we do not reject, right? So the very, very, very basic ones here to start. I'll give you a chance to get the easy one before you go to the hard one. If it's one tail, it's less than is one tail. Less than. Everything else should be pretty easy from there. All right, this one's not equal to, so it is a two-tail test. Again, this one gives me the test statistics, so hopefully these are just good refreshers on how to do this and help you out on the test a bit. The p-value is going to be the part that's shaded on the outside. They give me the p-value, which is 0.058. And then you have to answer the question, what is my level of significance? 0.10. Man. How much harder is that? That's probably a lot harder for y'all to see, but I can't. The chart that I use, just so we have it somewhere here on the review for the p-value, because there is one more p-value question. I think there's 2 p-value and 2 critical value. So we look at the level of significance. If the p-value is less than the level of significance, you reject HO, and there is evidence to support this one. I need some more room here. Okay. This is just how I remember it. If the p-value is greater than the level of significance, it's going to be the opposite. We are going to circle this one. So we'd say you do not reject. There is not evidence. So they have the nots go together. Not reject. There is not evidence. So you are trying to prove whether one's more right than the other. So on this one, our p-value is 0.058. Our level of significance is 0.10, so that is less than. So when it's less than, we are going to reject the null hypothesis. Usually it's never the B or C on these. Same thing with confidence intervals. It's always A or D. Because like A and D or B and C never make sense. They kind of switch it back and forth and do it the wrong way. I think it's pretty easy to narrow it down to a 50-50 chance. All right, so here's a full one. We got to do the full one here. This is a mean one where we are doing the critical. No, we're doing the p-value, so we're doing the hard one first. So critical value, the mean is equal to, the number we're arguing about is, always look at the last sentence, is different from 65. So the first one says equal, the next one says different, so it's going to be not equal. So this is a two-tail test, okay? The test statistic, we use that formula right there that they give us. So our test statistic is, I'm going to click the division bar first because that makes it easier to do. We do a sample of 67.2 minus 65 divided by the standard deviation, which is 22.8, divided by the square root of n. So again, just like we did on number 4, I think it was, if you sample more than 1, you have to divide by the square root of n. So this is going to be our test statistic. 0.5458. Okay. So now we would shade there. That's a big test statistic. This was, you're talking about the p-value being really big, wasn't it? Sorry, just double check and make sure I put everything in right. Oh, the standard deviation is 22.8. That's a huge standard deviation. My mean is 67.2 and my standard deviation is 22. So, yeah, that's going to be huge. Okay, I think that should be right. All right, to find the p-value, they do give you that hint right above the box right here. The p-value is 2 times the area under the curve to the right of the value of test statistic. I do not. So I'm going to type my test statistic in there, okay? I don't really, when I do a two-tail one, this is probably something that I do a little bit different. I always just use the left tail, okay? If I'm only finding the left tail, it would be negative, right? The left tail is negative. See down here, the left one, negative 0.5458. So if I'm finding the p-value on the left one, it would be this answer, but everything's symmetric, so I'm going to take it times 2 because I need both of them. I need the left and the right. So when I have two tails, I just always use the left one because now I don't have to worry about the 1 minus. Does that make sense? It says right here to find the value of the right one and then take it times 2. So the only thing different would be I'd do 1 minus and I'd do the positive tail. Does that make sense? It switches that back and forth and I hate it. I know why they do it. I figured out why they do it. If you want to know why they do it, is because, just really, I don't think it will confuse you. If my original number is 65 and I got 67.2, that's bigger, right? So they use the right tail. If it was less than, they'd use the left tail.
Oh.
And that's why they switch back and forth. I always just do the left tail because that's the one the calculator button uses. The calculator button always is less than, so I just use that one. Does that kind of make sense?
Yeah.
No?
You have to switch it back and forth.
I know, I hate that they switch it back and forth. So what I do on two-tail is I find, just pretend the right one's not there, right? And if I find this right here, I'm doing the calculator button and I do negative 0.548 and it finds this one. And then I take it times 2 because there's two tails.
Yeah.
Okay. That's what I always do on the two-tail one. All right, so let's press equal. That's a huge number, 2.5852. And now we compare the p-value and the level of significance. Let's go ahead and screenshot it before I do that. Try to find a good spot to screenshot it here. I want to undo that, so I have that right there. The p-value is going to be way greater than, but I really don't want to lose my numbers. The answer is D, okay? I'm going to go ahead and show you the answer. I'll pause here for a second, but the answer is D. It's not going to be rejected because the p-value is way greater than the level of significance. Okay. Sorry, I can't screenshot it all in one.
So this one tells you where it says the p-value, it tells you that you're gonna have to do it 3 times.
Yeah, I think, don't they all? I thought they all told you that. So we use this one because we find here to the left, so this tail right here is actually like 0.2926, but then you take it times 2 because 2 tails. Okay. I do it a little bit differently than they tell us to do it right here. If you do this one in the calculator, you would put 1 minus 0.5458. You'd find the right tail, okay? This is the right tail, 2 times the right tail, and this would be up here, would be 2 times the left tail. That make sense? All right, and then the last thing I do want to write here is this right here. In the calculator, we did 67.2 minus 65 divided by the square root is 22.8 divided by the square root of n. So you have all those numbers. I guess we need to do the answer here down at the bottom too. My p-value was 0.5852. My level of significance is 0.10. That is greater than. So we do not reject. Do not reject HO. There is not evidence to support H1, the alternate. All right, last one should be critical value. This is a proportion one. They're saying the first time using the site is 35%. Claim to reject that. So this looks like it's a two-tail one as well. So they're going to argue about whether it is 35 or not. Equal 35. And then this one would be not equal 35. So we get another two-tail one. This is part B is just to check to see if your numbers are good enough. You ask enough people and that kind of thing. So my N, we surveyed 64 people. So we do 64 times 35 is 22.4. And then what the next one is, if 35 people said yes, that means 65 said no, right? So 1 minus 35 is 65. So 35 times 60, I'm sorry. 100 minus 35 is 65, and then I do the sample 64 times 0.65 is 41.6. All right. This is a two-tail because it's not equal to. So now we got to find the critical values. 0.025 is a value that cuts off the area to the right. So they are using 0.025 because, we can walk through this, the level of significance is 5, so that means you get 2.5 on the right and 2.5 on the left. That's why they do 2.5. So all we have to do is put that in the calculator, and we get 1.96, 3 values. I'm doing 1.96, that's fine, right? I think 1.96 will be fine. We'll hope it is. And then the other side, you just do the negative. So everything is symmetric. So one's positive, one's negative.
I got an 83.
Awesome.
I'm happy with that.
Yeah. If you want to wait 2 seconds to talk about your grade, I'm on the last one. But
Okay.
all right. This right here, the test statistic. So we have our critical value. Did I get them both in there? Why isn't the other one popping up? There it is. Okay. The test statistic, this is the hardest formula that we have to do in the class. I hate that it comes here at the end, but it does. So what I do is I hit the fraction bar twice. I know that's kind of silly, but then I only have to do it one time, and it makes it a lot easier. So on the first one, oh no, I did these wrong. We did 64 people said they used the site out of 170. So on these, I was supposed to multiply by 170, not 64. That's what you get when you don't read the problem. Man, you're supposed to do 170 times 35 and 170 times 65. My bad. You do the total amount, not how many people said yes. All right, 64 divided by 170 minus 0.35. And then on the bottom, we do the square root of, I'm going to hit fraction bar, 0.35 times 0.65 and divided by 170. Ooh, I hit the wrong button there. 170. Okay. So this formula is the one that's bad in the calculator. 0.724. Undo it. Okay, so now it does look like it is not in the rejection region, so we do not reject, and there is not evidence to support. Let me write a couple things real quick. I think all our numbers are right there, so I don't really need the top part. So we're doing not equal to, so it's two tail right here. I did this wrong, but it should be 170 times 0.35 and 170 times 0.65. Okay. So I used 64 on accident, my bad. And then there's our number not in the rejection region, doesn't lie in the rejection region, not. We're looking for the nots then. Not in the rejection region, not rejected, not enough evidence. And this equals 0.724. Yeah, the critical value is so much easier. All right, I think that's your test, right?